Alright, this is a video that is going to cover algebraic story problems. This comes from, most of these problems that I'm going to work through come from 3.1 section exercises part B. And there's story problems in part A as well. We might go over one of those, but there's not as many as there are in part B, so we're going to take over and look at the story problems in part B. So let's look at this first one. I have number 11 written right here. It says 27 is 6 more than 3 times a number. What is the number? So reading a story problem, I read it through once. Then I say, okay, well, we know that 27 so is equals. That's something to watch out for. Is always equals in these equations. So when you see an algebraic equation, is the equal sign. So now we know that 27 equals sign 6 more. So 6 more means addition. Plus, then 3 times multiplied a number, x. So times is always multiplication. A number is always a variable. And then it wants to know what is the variable. So in these problems, it's more about knowing what things mean than it is actually doing the problem, because from here it's pretty easy. What's difficult is putting the problem together. So let's run through how this problem was put together again. 27 is our equals sign, right? So we know that 27 equals something. We know that so far. Now 6, that's a number, so we can put that in. 27 is 6 more. So 6 more means we're probably adding 6 to something. So 6 more, okay. So we're adding 6 to something. So I put that down, 6 plus 3 times a number. 3 times x. 3 times a number, and a variable. 3 multiplied by a number. All right, now we solve it. First, we need to get rid of the 6. So we're going to minus 6 because we're adding 6. So we can say a plus here. Because we're adding 6, if we minus 6, we'll get 21 equals 3x. Divide by 3. X equals 7. Let's run through that again. If 27 equals 6 plus 3x, we know we added a 6, so we have to do the opposite. Minus a 6, right? We're going through the operations that we did to x. And we got to work backwards through the order of operations because we can't work from the multiplication. If we did that, if we tried to divide by 3, we would divide this by 3 and this by 3. 27 doesn't divide by 3 well. 6 divides by 3 well, but then it's hard because we have to add a fraction over. So the best thing to do is actually minus the 6 first. That's what you have to remember. Always do your addition and subtraction first when you're working an equation backwards because we're working through the order of operations backwards. So 6 plus 3x, then divide by 3. When we divide by 3, that gives us 7. X equals 7. Now let's work through how to set up another story problem. We don't really necessarily need to solve it. I just solved this for your benefit. I'm going to make another basic algebra video that will go over solving. So we're not going to really do solving here. We're just going to do how to set up the equation. So that was number 11. And if you need to watch that again, just go back to the beginning of the video and watch it again. There's nothing wrong with stopping it and going back and watching what you need to watch again. Let's do the triangle ones are always hard. Let's do a triangle one. Though the triangle ones are fun. Alright, I have created a triangular garden such that the largest side is 6 feet less than twice the smallest, and the medium side is 5 feet larger than twice the smallest side, or than the smallest side. If the total perimeter of the garden is 47 feet, what are the lengths of the 3 sides? Alright, so we know something right off. we know that we have a triangle, so we're going to build a triangle here. All right, now this says that we know the smallest side, so we're going to call that smallest side x. Okay, we know that the smallest side is x because it says whenever it mentions the smallest side in here, it doesn't say what it does. It just says that this one is 6 feet less than twice the smallest. This one is 5 feet larger than the smallest, and so we see that the smallest is actually x because we don't have anything that goes with it. And that'll make sense here in a second. Now let's read through it again. I have created a triangular garden, so triangle garden, such that the largest side is 6 feet less. So that's something. The largest side, so this side right here, is 6 feet less. So minus 6 feet. Less means minus. Then twice the smallest side. Okay, so we'll stop there for a second. So twice the smallest side, so smallest is x, right? Smallest is x, we know that. Okay, so that means that's 2x minus 6. Okay, that's cool. So we know that side is 2x minus 6. This side over here is 5 feet larger. Okay, well that's something to know. So the medium side is 5 feet larger than the smallest side. So that means that if the medium side is 5 feet larger, then that's an addition, right? Larger means we're adding. Okay, so we say 5 plus x. Now that's how we build the initial triangle. That's how we build the initial triangle, but the equation is not solved. We don't know what x is, and we want to know what the lengths of the three sides are, so we're going to name it the small side, so side 1. We'll call this one side 1, this one side 2, and this one side 3. We don't know what those lengths are, so right now they're a mystery. And that's what we're trying to solve. We don't have that answer yet. I mean, we have it in terms of x, but we don't know what x is. So we have to use an equation to solve. If you remember your perimeter equation for triangles, P equals S1 plus S2 plus S3. Now we can solve this. We can say x, so side 1, plus side 2, 5 plus x, plus side 3, 2x minus 6. And we know P, because P is given right here. This is P. Because the total perimeter is 47, so we know that this equals 47. Now we can solve. We can say x plus 2x, right? So we're going to combine like terms. Remember that. That's a basic algebraic operation. We're combining like terms. Each of these has a 1 in front. 1 plus 2 is 4. And the x is still there. Then 5 plus the negative 6 is minus 1. Okay. So let's go over combining like terms again. Find everything with an x, add it together. Find everything without an x, add it together. So everything with an x, 1x plus 1x plus 2x. Okay, that equals 4x. Now we add our other terms together, and that gives us minus 1. So we've combined like terms, because this term goes with that term, and these 4x's come together. Now we're going to add 1, because we have a minus 1 there. So we have to do the opposite operation. 48. And then equals 4. Now if we divide by 4x. Now if we divide by 4, x equals 12. All right, so that was just solving to get x. Now we have to plug it back into these equations to solve for what we've got. So we know that x is 12, so well, that makes it nice. Side 1 is then 12. Because if x equals 12, then this x has to equal 12, because that's what we solved for. Now on side 2, x is not just that, x is 12 plus 5. Which is 17. This is not 72. Let's fix that, because this is not 72. This is just 12. All right, and then S3 is 2x, so 2 times 12 minus 6, which is 24 minus 6, which is 18. So those are the lengths of your sides. That is how you would solve that. If you need to, watch this video over again and it'll help you out. Right now, since we're running low on time for the rest of the video, what we're going to do is we're going to go through different things you'll see in an equation that mean things. Or that you'll see in a word problem that mean things for an equation. I'm going to write out some stuff that you'll want to know. All right, just kind of clearing that away. And again, you can go back and watch the rest of that. So the first thing is equals the equals sign of the equation. It is the equals sign of the equation. More equals plus. Less than less, whenever you see the word less, that usually equals minus. When you say times, that equals multiplication. So this is subtraction. This is addition. Times equals multiplication. And you'll see division for division. That one's pretty easy. You'll see divided by, and that equals division. Or you'll see a fraction. So it's either divided by or a fraction for division. Then there's, you'll see things in the problems like some number. Something or some number. That is your variable. It can be anything. So the variable can be any letter. And then it'll tell you a word like solve or find. That's how you know to set an equation up. And to set an equation up, you need to know how everything relates to your unknown. So usually these words, more or less, times divided by something, some number, you're going to find out how the numbers that they give you relate to your unknown. Your unknown is what's important because that's what you're trying to find. And these equations are all about trying to find the unknown. And so that is how you would solve word problems through algebraic functions.